Hi everyone, this is EMP, Electromagnetic Precursors for Earthquakes. Now remember in the last video I showed you this TEC map, aka ionospheric electron density, aka ionospheric capacitance. We used the capacitor model and this is what we're seeing here, extreme capacitance, the red and white streak right across the equator and the black blob, blue around it. Really got to watch out for those. Beware the black blob, indeed. And another heads up for North America here. This whole highlighted region here is definitely subjected to ground charging beneath the ionosphere. Now, looking at Pewinuk, Canada's neutron monitor at that time, in the beginning of the 12th, you can see right here, pretty big neutron spike, neutron density spike, aka electrical discharging of the capacitor, and a few smaller ones after that. And did have another earthquake off the coast of Oregon, magnitude 4.6, 1847 universal time. Now, looking at Nain, which is in Labrador. This is their neutron monitor, and at about 8 universal time, had a discharge there and another discharge just after 1400 universal time. So if we look at this is Victoria's magnetometer data, you can see here at about 8 universal time, huge spike in magnetic activity there, and going all the way up to 1400, then just after that 1500 universal time, huge spike there, and then just after 1800 universal time, had the earthquake there. And back up the ground-based observations further, see same thing, Fresno, California's magnetometer, you can see a magnetic spike there, and then it goes all the way up, all the way to 1500 again, and there we had the earthquake just hours after that. So just to refresh the capacitor model, I always like to use the analogy of the plasma lamp because it's very, very easy to understand. So easy to understand that literally my parents can even understand now how space weather affects things on Earth here geomagnetically. And we get earthquakes and volcanic eruptions as well. So just to refresh your mind, keep it fresh in your mind's eye, remember the outer layer, the plasma lamp here, glass sphere, is one plate of the capacitor. You can look at that as a plate of the capacitor as a battery, and the inner sphere here is where we get ground charging of the Earth, and then in between is this electrical discharges, which we can view as neutron density, or way simpler than that, just electrical discharging of the capacitor. Now, really wanted to show you is gamma rays. Now remember the S-curve I was talking about, which we usually see spike in gamma rays here just before the 11th and 0100 universal time. It's where we usually get that interval of extremely heightened capacitance, and here we go again, dips down all the way up just before another interval on the 12th, which will be another story for another day. but I really wanted to show you this huge spike in gamma rays here. This is one of the biggest, if not biggest, that I've seen, no joke. So about 1200 universal time, and here's Japan's magnetometer data. So we had that spike, gamma ray spike at about 1200 universal time. Magnetic activity starts going up, 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 all the way to peaking at about 2100 universal time. And then here's China's magnetometer, which shows magnetic activity going up as well. And another one in China at Beijing, showing basically the same thing. But interestingly, so you got to check the magnet. Not always do you see the huge spikes in magnetic activity. Like I showed you the magnetometer data for China, but they actually had more activity. So, and this is Russia's magnetometer. So there's the gamma ray spike. See a little bump there at 1200 universal time. And huge spike here just after 1800 universal time. So we did have another earthquake, magnitude 5.4, Kuril Islands. That's why I was showing you the Russian magnetometer data. So just after 1711 universal time, so remember that. So here at 1700, big peak in magnetic activity there, and boom, we had the earthquake. So it's interesting, sometimes you'll see these gamma rays, which is right at the top, energetically speaking. We can't quantify anything more powerful than gamma rays as of yet. Sometimes you'll see instantaneous action at a distance, like I showed you in a previous video, and there was an earthquake literally at the same time as that gamma ray spike, aka electrical discharging of the capacitor now. There was definitely a time delay between that and the Russian earthquake this time now. Why is that? Well, here we go. Here's the IMF, Interplanetary Magnetic Field data, aka the sun's magnetic field, and right here we have 1200 universal time. Right after that, magnetic activity starts to go up, 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 until we had the earthquake at about just after 1700 universal time there. And here's Karuna's rheometer, which shows ionospheric induction, 1200 universal time. We had the gamma rays going off, and then here's a huge spike in induction. And then basically right after that, boom, we had that earthquake. So it's not hard to see what's going on there. And back that up one step further, also here's Karuna's proton magnetometer. Just a few hours after the gamma rays kicked in, there's a peak at about 1500 universal time, and just hours after that, 1711 universal time, we had the earthquake. Now that's pretty much all I wanted to show you for this episode, because I got to break this down into much smaller segments, or else I'm ending up approaching the 10-minute mark, which is a bit long for these videos. But like I said before, I've got so much data with the space weather that's going on lately, and it just keeps getting more interesting every day. Um, that's what I wanted to show you for now. Thanks for watching, folks. Take care.